Hey, KubeCon. Happy to be here. Let's dive into our presentation.
Today, we're talking about managing applications in production and specifically using Helm versus YTT and kapp to do so. I am Shatarupa. I work at VMware, and I have been working on deployment and packaging for a few years now, previously working related to Cloud Foundry and now on Kubernetes. That's a picture of me in Glasgow back when traveling internationally was still a thing.
And I'm Dmitry. I also work with Rupa on deployment group. I've been bouncing around in VM and container orchestration for a while. Happy to be here.
So in today's talk, we'll cover a few things. We'll talk about what we really value in deployment tools and what we're looking for there. We'll see how a deployment workflow goes on Kubernetes. What are some challenges we faced with Helm in regards to this deployment workflow? And then finally, we'll talk about some insights we've learned from deploying in production at various scales, and talk about why we built YTT and kapp based on our experience managing these applications in production. So what do we really want from deployment tools? Well, from our experience, both with large-scale production applications and smaller scale, these are really the things that we've come to value. So first is safety. We want to be able to catch mistakes before they happen, and especially so in production. We want reliability from our tools, so we want it to be predictable. We want to know what is going to happen is what we expect to happen. We want transparency, so we want to know what's going on with the tool, what's going on with our deployments while it's going on. And this kind of flows into the next point of debuggability, because we can use that information to fix things when things inevitably go wrong. And then finally, we want speed. So we don't want the tools to be slow. We want to keep those fast feedback loops so that we can make changes. Once we have these things, ultimately, we want the deployment tool to be boring. We want it to get out of our way so that we can go about and do the things we actually set out to do. So Helm is widely used in the community today. And so we looked at Helm because we saw lots of people having good experiences with it. And we used it to deploy third-party software. We wanted the same thing to deploy our own applications. We wanted the same tools and workflows. However, when we started using Helm, we faced various challenges, some due to the design choices that are made by Helm, and some concrete bugs that we encountered. And we'll discuss both of these categories in this talk and describe why Helm wasn't the right choice for us. Let's talk a little bit about the end-to-end deployment workflow. Now, in our experience, this can really be broken down into these 4 discrete steps. And thinking about each of these as scoped kind of smaller jobs to be done, such as authoring configuration, then taking that configuration and packaging and distributing it, then consuming that configuration, customizing it to your environment, and then finally deploying it. And thinking about this in each of these steps makes it so that it's more transparent and we know what's going on in each step. And it's safer, so we can catch mistakes as they happen in every step, rather than learning at the very end that something went awry. A helpful terminology that we found that we'll use throughout this presentation is thinking about the configuration author and configuration consumer. And for third-party software, the author and consumer are different, right? So we're consuming software that is written by someone else. However, for software that we write and deploy to production ourselves, we play both of these roles. And ideally, we would like the tools and workflows to be the same for both configuration authors and consumers. And if we can think about these things, these 4 steps as separate jobs to be done, then we kind of started wondering, can we create clean API boundaries between these so that consumers can pick and choose tools of their choice for each of these pieces? And we'll discuss this approach more in this talk. But first, let's get started with authoring configuration. So the main problem we're trying to solve is we want to be able to provide some mechanism, such as a template, to allow users deploying software to customize it to their needs. Now, most templating tools out there, including Helm, are based on text templating. And here's an example that is using Helm and will look very familiar to many of you in the audience. One drawback with text templating and in this example is that I have to constantly think about constructing my own YAML, and that is error prone. So to have a safer tool, I'd like stronger guarantees that whatever I write always produces valid YAML, and I don't have to worry about the right indentation and coding values for YAML escaping. I'd like the tool to be able to take on those problems for me. Another drawback with this approach here is that I have to think about configuration knobs, validations, whatever else, while also making sure that I'm constructing valid YAML. And intuitively, I want to think about the data and its structure separately, and then think about serializing to YAML as a separate or a final step. Now, in this example, we're doing the same thing as what you saw above or before, but with YTT. And you'll notice that I'm writing valid YAML the entire time. So I can focus on the values that I'm templating instead of thinking of constructing that YAML. And then the data values pod annotations here is provided by a configuration consumer, and it's associated with a particular YAML node by YTT. Now let's see an example that highlights the advantage of using data structures instead of text. In this example, we want to build a config map with a host port and a lowercase output name. Notice in the config function at arrow 1, I'm returning a map containing these key value pairs, not text. This then enables me later to serialize this map to JSON when converting or when inserting it into the config map at arrow 3. Since this is a simple example, I'm just directly taking this map and converting it to JSON, but you can imagine performing other more complex operations on the map too. The key point being that since it's a map, I can modify it and transform it and take advantage of that structure instead of treating it as text. Note that you don't always have to manually serialize all data structures. Next to arrow 2, you'll see I'm using the output of the labels function, and YTT will serialize the output of this function to YAML for you. Taking this concept of using functions and thinking in data structures a little bit further, we realized that actually templating can be viewed as one big function. There are some parameters on which the templates run, and there's a resulting structure. You can either modify this structure further, or if you're done, you can serialize it to YAML and then get the rendered configuration. To make things easier for the configuration consumer, we have found it useful to have parameters or data values follow a particular schema. Now, in our templating adventures, one thing we encountered often is that we were in situations where we wanted to install open source software or install third-party software. In this case, we wanted to install a CNI called Calico. The instructions on Calico's website mention downloading Calico Taifa configuration YAML file, and then changing the number of replicas based on your environment. And I could use customize overlay to do this, but I wanted something which we could do within this templating tool and following the paradigm that we shared before. And this is why YTT overlays are helpful. Overlays with YTT provide you with a way to patch existing YAML. And so you'll see on arrow 1, we get the Calico Taifa YAML, and then we apply the YAML or apply the overlay on arrow 2. And then finally, on arrow 3, you'll see there's the change replicas, which is the overlay we're applying. So change replicas has also been generated within YTT. So now let's talk a little bit about the execution environment of those functions that we're running. Prioritizing safety, we wanted to make sure that the environment did not have access to entropy, network, disk, the OSA environment, or time. This way, the execution environment is always the same, and YTT is reliable as a tool. It also makes YTT stateless. Now, you may wonder, if you don't have access to these things, that means you cannot generate secrets on client side or generate random strings. And that's true. We recommend generating secrets and storing any other state on the cluster itself. And this is what all of this looks like in action. So if you were to use YTT, you could have your templates in a config directory or any other directory of your choice, and then apply values to it. And then YTT would render the YAML for you, which you can then use with the deployment tool of your choice. In this case, we're using kubectl.
So let's talk about packaging and distribution now that we've figured out how to write our configuration. So what is a bundle? There is no formal definition of a bundle as far as we know. However, the way we look at it is there needs to be some kind of a bond between a set of configuration and a set of images that that configuration uses. Now, as all of you know, Helm includes packaging component in its tool. People distribute charts over Helm repositories. I think it's a TGZ that gets put in the server somewhere. More recently, though, Helm has been encouraging people to use registry as the storage for Helm charts, right? So what you do is you take the Helm chart, you run the command with Helm, and that Helm chart suddenly becomes an image inside that registry, right? And ultimately, somebody else can pull it down and use it, right? Now, Helm itself does not actually care about what images you're using within the configuration, right? So it's really just the top part of what Helm is doing. It's dealing only with the configuration image. For our own use cases, we actually need something more specific, because in a lot of our environments, we need to bring down the images that are being used by the configuration into customer registries to support cases like firewalled environments or air-gapped environments. We need effectively a way to keep track of what are these app images that are being referenced by the configuration. And so we see bundle as one thing that combines the two together. What's also important is that we want to retain for the bundle image the same digest throughout. That way the customer is absolutely sure that they're installing the software that they originally wanted to install, even after it gets copied between various registries. So how does this look? Well, this looks something like image package push with a set of files. This could be any set of files, could be YTT templates, plain YAML, maybe even a Helm chart source. And ultimately, it's image package pull from a different location to download the bundle. And maybe in between those two commands, you do end up using image package copy command to transfer the bundle from one repository to another. Well, now that we're done with packaging and distribution, customizing configuration is our next step in our journey. We've seen out there a lot of Helm chart authors run into a problem that we call API mirroring. Over time, consumers of the charts request to have various configuration knobs be added to the Helm charts. And that becomes a big problem for the authors, right? Because various users may need to have various use cases satisfied, and ultimately the set of values, the template values grows maybe even to thousands of options. That's not something that we like, and we don't think that's a scalable approach. So let's throw that out. Ideally, the way we look at solving this problem is saying that there is a percentage of configuration that's very common to everyone, right? And that should be passed in as values to the templates, right? So Helm values or YTT data values. Once the template does its job and returns a data structure back to us, we should be able to use a tool like Customize or YTT overlay to apply certain set of changes to that YAML and finally spit out the YAML for the following steps. YTT overlays is a feature of YTT, so it's convenient to have the various functionality that you can do in your templates to be also done within the overlays. So we think combining the templating and overlaying approach is one tool, is a very flexible and effective approach. So this is how overlay typically looks like. It has a part about describing how to find a particular YAML document to modify within a stream of documents. So in this case, it will find the single deployment. YTT will raise an error if it finds more or less. You can tweak those settings, of course. And then it has a second separate section that defines what actually to change within that YAML deployment, within the YAML document that's been found. And in this case, we're setting a priority class name to important. So here's maybe a more complicated example. We needed for our dev environments to shrink their footprint. So we wanted to say, find any of the deployment, daemon sets, stateful sets. If they have init containers, go ahead and for each one of those containers, remove the resources section and remove the liveliness probe resources, readiness probe, and so on and so forth. So we had to cut this overlay short for this slide. Very convenient. And so this is how it ends up to be looking on a command line. You combine, you extend that YTT invocation to include additional files, and those files may include overlays. And so you're able to specify your templates, your data values, your overlays, all in one command. So that's it for customizing configuration. Let's take a look at deploying. Deploying step ultimately boils down to taking configuration and putting it into a cluster. We've had some challenges doing deploys in a repeatable manner. We've faced various errors and various cases that we're surprised by, but of course we also had successes. And so this is one of the example errors that we've seen sometimes occur that was pretty hard to debug. We've also had somewhat of a lack of a confidence about the operations that will take place because Helm was not quite transparent about the changes that it was going to make to the cluster. And even if there were options to tweak how the deploy would happen, it was still not quite clear if this tweak, like a force flag, would actually have some unintended consequences. So we thought, well, there's got to be a more lightweight way to make us comfortable do the deploys. And so we wanted to write a tool that really focuses on safety, reliability, and transparency. And so how do we actually see deploying to Kubernetes work? Well, we wanted to build up on a basic Kubernetes concept of labels, right? A collection of resources that has the same label, we see it as a Kubernetes application. Nothing else really on top of that. And of course, over time, as you changing your application, some resources will be removed, some updated, some created, maybe tweaked in other ways. And so we wanted that to happen for all of our applications consistently. So let's actually jump into a demo and take a look at how is it actually possible with this tool that we've made. So here, I'm going to type in kapp-ls to list the applications on my cluster. This cluster does not have currently any applications, so let's actually add one. We're going to call it app, and we're going to give it an initial YAML. And so what we see on the screen over here is that kapp will tell us before doing any kind of a change to the cluster, what's actually going to happen. We're going to create a deployment, we're going to create a service, and then we're also going to wait for those resources to reconcile. So let's press yes. Now at the same time, let's take a look at that configuration. Configuration is very simple. It's just a basic service and a basic deployment. We do have this environment variable that we call hello message that has a particular value. We're using an existing Docker image. So nothing out of ordinary. So a few seconds later, kapp tells us the deployment has reconciled, right? So at some point it saw that the container was creating, the pod eventually became ready, and kapp succeeded over here, right? So this notion of having a clear log of what's happening to your cluster while it's happening is very appealing to us. A summary of the changes that's about to happen before they happen also increases our confidence that we're actually making a good change. And also even a convenient tiny little line over here that tells us which cluster we're targeting gives us even gives us a little bit of a boost of, yes, we're actually doing the right thing. We're not deleting production cluster maybe when we meant to update the staging environment. So let's actually take a look at this application. It is, if you notice here, 6 resources, even though we only deployed 2 resources, right? So kapp has capability based on those labels to actually track some of the resources that cluster creates, right? As you can see over here, the owner column specifies kapp and cluster as different owners for different resources. So kapp only created deployment and service. So that's somewhat convenient. We can even see it in the tree view where some of the ownership references are being accounted for. And so deployment owns a replica set, owns a pod. And even for some of you who don't use some of the other external logging tools, it might be useful to be able to just say kapp logs -f-a app and actually see a live log from all of the pods within that application. Of course, you can also use other tools because the pods are labeled. You can use the other tools to track the logs in bulk. So let's go ahead on the second step over here and apply a change to the application. That's ultimately what we're here for. So I will go and throw in this -c flag. It will show the changes that it's about to make. It has a nice colorful diff. It's telling us that we're going to create a new service. The service got renamed from simple app to simple app node. We're actually changing a deployment a little bit. We have a value being switched to a config map reference. We have a config map that we're going to reference. And then finally, we have the deleted service. So let's go ahead and apply that. And again, we'll see the progressive log. All right. So before we jump into the next file over here, let's take a look over here for a second. So we have the config map and we have the config map reference. Now, some software cannot reload configuration off of disk as it's running. Now, even in some cases, that may not be a good idea because you may not want to apply that configuration to the entire set of pods that you might be running for your service, right? And so we have this feature in kapp called versioned resources. It makes the resource immutable. So any change to the config map will turn to be a new resource. So let's actually apply that and let's see what happens. So we'll see in our summary that we're creating a new config map that has a suffix version 1, and we're also deleting the old config map. And we also have a change in the deployment because kapp realizes that that config map is being referenced, so it will update that reference. So that update will go ahead and complete. And just to prove that this feature works, when we change the config map, it shows you that, hey, we're going to create a new config map with version 2. That's the change from the previous version, right? And then the version will be also used in the deployment correctly as well. So let's go ahead and apply that, and we'll see that the deployment kicks off. Now in Helm, this functionality really is up to the user of templates. The template author has to do a little bit of manual bookkeeping. They have to, let's say, run the content of a config map through a digest and add that annotation onto the pod. We think that a first-class support for this kind of a feature is more in line with how we use some of our tooling here. So let's go ahead and so I've made an update to BYAML, all right? And so what is in 3A? In 3A, we're adding a new resource, a job. It's a dummy little job that supposedly does the DB upgrade. That's not, of course, happening in real life. All we're doing is sleeping for 5 seconds. So let's go ahead and do that. So we'll say 3A. We'll get our nice summary over here, and then we'll apply that. Do note that immediately we actually see logs from this job in line within the deploy progress. That again goes back to the transparency of what's happening in the deploy, right? And this is because of the little annotation that we added over here telling kapp, hey, please show this logs in line. So, okay, we have this job now. It's doing a database migration. Let's go ahead and actually apply a change to it. And we're going to change just a tiny little bit over here. We're going to change the job to say from done to finished. Let's go ahead and see what happens. Oof. So a big error. This error is coming directly from Kubernetes API. We actually want to format it in a better way, right? We try to pull out individual pieces in the list of the error reasons. And one of the reasons why I can actually see this is that we have spec template, and spec template field is immutable, right? So we cannot change it. So this is one of the interesting things about Kubernetes. Some resources may decide that something is not allowed to be changed, right? And there potentially some other way to cope with that, maybe to recreate a resource. For pod disruption budgets, for example, before Kubernetes 1.15, that was the case. Couldn't update it, had to delete, create. So we actually have a feature that we think is more resilient to production usage. We think that a user should have to annotate a particular resource and state that it is safe to recreate. So this is somewhat of a different decision point compared to just adding a force flag for all of the resource potentially, right? Because who knows, maybe some resources will fail with an error and they may have to get recreated if the resource for whatever reason is invalid. So let's go ahead and apply that YAML with our annotations, and note that actually kapp tells us that, hey, there's a possibility that this will be replaced. And so we see our log again. We see that job is successfully updated, really recreated in this case, and it finishes. Great. All right. So we've got one more example over here. So we have this job, but the problem is job is running at the same time as the deployment being updated, right? Now, for some applications, that's perfectly okay. Some applications, though, may want to actually do a DB migration before the application, let's say, starts, right? Now, there's various ways how to deal with this kind of thing. You may create an init container, but we think a more first-class feature is deserved in this case. So what we're doing here actually is we're annotating job to be able to be scheduled as an update before the deployment. And the deployment is also annotated to say, hey, I am the deployment, right? Now, this is not specific to jobs and deployments. This could be applied to any resources. So let's go ahead and actually try that out. So we'll see what the diff is here. So one, we're changing config map, which will trigger the deploy. And as you can see over here, deploy is changing. We're also changing the job, so it will actually run. So let's see what happens. So as you can see, we got a job running over here. We got some logs coming out. We're waiting. We're waiting for it to succeed. Okay, it succeeded. And then finally, after it succeeded, we actually have a deployment update running, and then it finishes. So the ordering here is really not a special feature to kapp. It is quite similar to namespace and CRD features within kapp, ordering of those. It's the same system. Kapp just exposes and lets you use it yourself. We don't treat CRDs, for example, any different from any other resource. So happy to deploy it. And as an example, if we take a real out there app, cert manager, we can actually see how it all works out. So here's a few resources. There's a single YAML file. You don't have to split your CRDs or whatnot, and you just let it go. And kapp will go ahead and deploy cert manager. And in a second or two, all the pods should come up, and kapp will tell you cert manager is installed. There it is. All right, so let's switch back to our presentation.
So with the clean API boundaries and small building blocks, this is all beginning to look good. But ultimately, we said the goal of good deployment tools is to make it boring, to get out of your way. And how can we get there? How can we create a simple deployment experience? We'll see some examples here. So this is some client-side deployment examples if you're using CLIs. In the first example, we use YTT for templating, and then kubectl for deploying it. In the second example, we use all of the tools that we've showcased here. So we use image package to pull down a bundle, and then use YTT to template it with the appropriate data values, and then use kapp to deploy. And then in the final example, we continue to use Helm to template maybe some third-party software that is shipped with Helm templates, and then use kapp to deploy. And so with this, you can kind of see how, as we've talked about before, it really allows you to break down that deployment into these different pieces, giving you a little bit more visibility into what's going on at each piece. And CLI-based experience, as I showed before, is helpful, but really what we want is for this to happen behind the scenes, almost in a boring way. So ideally, you want this happening on your cluster. You want some kind of continuous delivery mechanism, especially if you're running in production. And that's exactly what we have with this tool called Kapp Controller. So Kapp Controller provides an app CRD, and that's what's here on the screen. And it tells you very clearly the three various things it's doing. So what is it going to use for the fetch stage? What strategy is it going to use? And it supports various strategies. What is it going to use to template? And again, different strategies there. And then finally, what is it going to use to deploy, in this case, Kapp? So in the fetch stage, right, with various strategies here, we can either use image package to get a bundle. We could use Helm fetch to go fetch some Helm charts. Or you can use back it with a Git repo. And so this is where you can kind of use it to do GitOps like workflow, and any changes to the Git repo, Kapp Controller will watch on and make changes appropriately. Similarly for the template, we're using YTT templates here, but you could also use Helm template. So what's next with these tools? If what we presented here, these ideas, they resonated with you, you can learn more on K14s.io. Try to use Kapp or YTT on GetYTT.io, GetKapp.io. We are always available and chatty on the K14s Slack channel on Kubernetes. So come talk with us, share how you template and deploy today. All of these projects that we've shared are open source, and the rest of the K14s tooling is open source as well. And we welcome contributions to any of these projects. And we love hearing how you use these tools. It really makes us happy. So do come chat with us. And we hope you found this talk valuable, and thank you for your time.